Up to this point, we have built structure step by step. Coherence above threshold produces stabilization. Directional variation produces metric structure. Non-uniform coherence produces curvature. Coherence, redistribution, produces dynamic geometry. Structural constraints restrict the form of that evolution. We now face the narrowing moment. Given all constraints already established, what is the minimal rule that coherence evolution must obey? Not a decorative rule, not one chosen for elegance. The simplest rule that satisfies every structural condition we have derived. Let us restate those conditions clearly. First, conservation under closure. Within a structurally closed region, total coherence cannot arbitrarily appear or disappear. Redistribution is allowed. Creation without threshold cost is not. Second, locality. Coherence must propagate through neighboring relations, no instantaneous global restructuring. Third, continuity. Redistribution must occur through gradual structural adjustment. Discontinuous jumps violate refinement order. Fourth, reciprocity. Curvature reflects coherence gradients, but curvature also influences coherence redistribution. The relationship must be mutual. Fifth, coordinate independence. The rule cannot depend on arbitrary labeling of stabilized elements. It must depend only on relational structure. These 5 constraints form a narrow corridor. Any viable evolution rule must pass through it. Now consider the simplest possibility. If curvature reflects coherence gradients, then coherence redistribution must respond to curvature configuration. Regions of high curvature correspond to steep coherence imbalance. Imbalance drives redistribution. Redistribution reduces imbalance. This is a feedback loop. So the minimal rule must relate change in coherence density to geometric curvature, not arbitrarily. Proportionally, but proportionally in a way that preserves conservation. That means any change in coherence within a region must correspond to a divergence of coherence flow across its boundary. No net change without flux. This immediately implies that coherence evolution must take the form of a continuity rule. Change equals flow. But flow must be driven by curvature imbalance, so flow must respond to curvature. Now observe something important. Curvature is already a second-order structural quantity. It measures variation of variation. So coherence, redistribution must relate to curvature in a way that preserves dimensional consistency. That means coherence evolution must be at most second order in spatial variation. Higher order rules would introduce instability. Lower order rules would not capture curvature feedback. So the minimal rule is second order. Now consider symmetry. The rule must treat all directions equally unless coherence distribution breaks symmetry. This prohibits preferred directions. It must also reduce to equilibrium when coherence is uniform. Uniform coherence must be a fixed solution. Now consider small perturbations. If coherence deviates slightly from equilibrium, redistribution must respond linearly at first order. Otherwise, small fluctuations would explode or freeze. This implies stability under small deviation. Combine all constraints. The minimal evolution rule must preserve total coherence under closure, propagate locally, respond to curvature imbalance, be second order in spatial variation, be linear under small perturbation, be coordinate independent. There are not many structures that satisfy all of these simultaneously. In fact, the simplest structure that satisfies them resembles a divergence of curvature-related flow equal to coherence density variation. That is not accidental, it is structurally forced. Now consider what this means. If curvature variation drives coherence redistribution, and coherence redistribution modifies curvature, Then the system forms a coupled differential structure, but the minimal version of this structure must balance curvature divergence against coherence density. This balance equation is not chosen. It is required. Any more complex rule would violate minimality. Any simpler rule would violate reciprocity. Now, consider equilibrium again. In equilibrium, coherence distribution is uniform. Curvature vanishes. Flow vanishes. The rule reduces to 0 equals 0. Stable. Now consider perturbation. If coherence density increases in a region, curvature increases. Increased curvature drives outward redistribution. Redistribution reduces density. System returns toward equilibrium. Stable. Now consider extreme imbalance. If coherence concentration is large enough, curvature response intensifies. But conservation prevents runaway growth. Flow increases proportionally. System resists collapse. Only if coherence approaches threshold boundaries could instability occur. This provides structural stability. Now observe something subtle. The minimal evolution rule does not require external parameters beyond stabilization scale. Its proportionality constant is determined by threshold magnitude and dimensional scaling, as discussed in episode 10. This means gravitational coupling emerges naturally from minimal coherence redistribution. No additional arbitrary parameter is necessary beyond threshold and dimensional structure. Now pause. Why call this minimal? Because it contains no unnecessary terms. It relates only curvature variation and coherence density variation. It preserves conservation. It preserves locality. It preserves reciprocity. It is second order. It reduces to equilibrium smoothly. Any attempt to complicate it would either introduce instability or violate structural constraint. Now, consider comparison. The field equations of general relativity relate curvature to energy, momentum, density. Our minimal rule relates curvature to coherence density. The structural form aligns, but again, alignment is not identity. We have derived necessity, not numerical equality. Now consider implication. If gravitational dynamics is the minimal coherence evolution rule, then gravity is not a separate interaction. It is the geometric expression of stabilization balance. Gravity becomes structural housekeeping, not force, not field imposed on background, but balance enforcement within coherence flow. This reframes gravity entirely. Now step back across the arc. Difference led to refinement. Refinement led to stabilization. Stabilization led to threshold. Threshold induced metric. Metric variation induced curvature. Curvature coupled to coherence redistribution. Structural constraints narrowed the evolution law. Minimality forced a specific form. We are now standing at something powerful. We did not assume gravitational equations. We cornered them. The corridor is narrow. If physical gravitation matches this minimal structure, then it is not arbitrary. It is inevitable. In the next episode, we turn to dimensional selection. Why does large-scale stabilization prefer a particular number of independent directions? Why 4 and not 3? Why not 5? Dimensionality cannot remain unexplained, and if dimension emerges from generator structure, then its selection must also follow structural pressure. That is where we go next.